Welcome to a journey through the hidden forces that shape our universe. For centuries, gravity has been a silent architect, pulling planets, guiding stars, and anchoring us to Earth. But what if gravity is more than just a force? Today, we'll explore a revolutionary perspective, the trinature of matter and the electromagnetic whispers that may underlie gravity itself. Prepare to see the cosmos through new eyes, where waves, charges, and mass unite in a cosmic symphony. Let's begin by revisiting the classical and quantum views of particles, and then venture into the heart of gravity's enigma. Classical mechanics, a particle is a simple point of mass, a tiny solid dot in the vast expanse of space, but quantum mechanics transforms this view. Here, particles are not just points, they're also waves, rippling through the void, sometimes behaving like matter, sometimes like energy. This duality has fascinated scientists for generations, revealing a universe far more mysterious than we once imagined. Yet even this wave-particle duality may not tell the whole story. What if there's a third aspect to every particle waiting to be discovered? Beyond the familiar wave and particle lies a vibrant, often overlooked property: electric charge. Charge is the source of attraction and repulsion, the spark that animates matter's dance. Imagine every particle as a trinity: a vibrating string, the wave; a steadfast point, the mass; and a defiant charge, the force. This trinature is etched into the very fabric of reality, shaping everything from the tiniest atom to the largest galaxy. By embracing this trinity, we open the door to a deeper understanding of gravity and the universe itself. Picture a single kilogram of matter not just as a lump of mass but as a symphony of vibrations. At its core, it's a string humming with primordial energy. Nodes of vibration intertwine, igniting sparks of charge at their intersections. This is the stringed crucible where matter's hidden orchestra plays. Each thread, each node contributes to the particle's mass, charge, and wave-like behavior. This vision challenges us to see matter not as static, but as alive with dynamic forces forever in motion. Let's break down the trinature of a 1 kg particle. First, the string's wavelength is unimaginably tiny, a whisper from the dawn of the universe. Second, the mass anchors the particle, giving it weight and presence. Third, the charge, though subtle, holds the power to attract or repel. Even particles that seem neutral hide a faint ember of charge, calculated from the interplay of gravity and electromagnetism. This mathematical trinity is the foundation for understanding how matter interacts and how gravity might emerge from deeper forces. Gravity has long been a mystery. Newton described it as a universal force pulling masses together across the void. Einstein reimagined it as the curvature of spacetime, where massive objects bend the fabric of reality itself. Yet even these great minds left questions unanswered. What truly causes gravity? Is it a geometric illusion, or is there a deeper electromagnetic origin? As we peel back the layers, we find that gravity may be woven from the same threads as charge and time, hinting at a profound unity in nature. Imagine time as a river of positively charged particles, surging at incredible speeds. These time particles generate electric and magnetic fields crossing each other in a cosmic dance. Space becomes a battlefield where these fields clash and intertwine, creating a lattice of light and shadow. When dense objects like planets or stars block this flow, they create regions of repulsion, shaping the very structure of space around them. This interplay between time, charge, and space sets the stage for gravity's mysterious pull. Time's charged pilgrims encounter a massive object, their flow is disrupted. Picture a stream forking around a boulder, except here the boulder is Earth, and the stream is a torrent of positive charges. The surface of the planet glows with innate charges, repelling the incoming flow. This cosmic hydrology creates a balance of forces where attraction and repulsion shape the movement of matter. It's a ballet of fields and charges, with gravity emerging as a subtle yet powerful consequence. Newton's law of gravity is simple and elegant. Every mass attracts every other mass with a force proportional to their masses and inversely proportional to the square of their distance. Einstein took this further, showing that massive objects curve spacetime and gravity is the result of this curvature. But what if both are only part of the story? By introducing charge and time into the equation, we begin to see gravity as a dance of electromagnetic forces, not just a geometric effect. Gravity's force can be reimagined using both mass and charge. When two objects interact, their charges and masses combine in a complex equation, blending gravitational and electromagnetic effects. For objects in motion, the equation becomes even richer, accounting for the changing distance and the flow of time. This new perspective suggests that gravity is not just a pull between masses, but a dynamic interplay of charges, fields, and motion, a symphony of forces that shapes the cosmos. Imagine throwing a stone into the sky. As it rises, it defies gravity for a moment, tracing a graceful arc. But beneath this simple motion lies a complex web of forces: electric fields, magnetic fields, and the subtle influence of time's flow. The stone's journey is shaped by these invisible threads, each contributing to its path. Gravity in this view is not a single force, but the sum of many, each playing its part in the stone's ascent and fall. Space curvature is more than just a bending of geometry. It's the result of electric and magnetic fields clashing, shaped by the flow of time's charged particles. When these fields meet resistance, they bend and warp, creating the effects we interpret as gravity. This electromagnetic lament is subtle, often too faint to notice in everyday life, but it becomes crucial in the grand ballet of planets and stars. How do planets and satellites move in their orbits? In the grand ballroom of spacetime, two electromagnetic forces, one attractive, one repulsive, choreograph their dance. The Sun and Earth, each with their own charges, interact through both core attraction and surface repulsion. The result is a delicate balance, where orbits are maintained by the tension between these opposing forces. This duality is the secret behind the stability of the solar system. Visualize the Sun and Earth as dancers in a cosmic quadrille. The Sun's positive core and Earth's negative shell create arcs of attraction, while blocked time particles at their surfaces generate repulsion. The distance between them is not just empty space but a tapestry woven from electromagnetic threads. The result is a stable orbit where gravity is the music and charge is the rhythm. Gravity's true nature is revealed in the interplay between innate attraction and blocked repulsion. The core charges of the Sun and Earth draw them together, while the block-time particles at their surfaces push them apart. The balance of these forces determines the shape and stability of planetary orbits. This dual electromagnetic origin of gravity challenges us to rethink what holds the universe together. Equations governing planetary motion become a planetary psalm, blending velocity, distance, charge, and magnetic flux. Each variable plays a role in the cosmic symphony, ensuring that planets remain in their orbits and that gravity's song is heard throughout the solar system. This mathematical harmony is the foundation for understanding both the predictability and the mystery of celestial mechanics. Gravitons, the hypothetical particles of gravity, are mere whispers for massive objects like Earth, but for quantum particles these whispers become a roar, dominating their behavior. The interplay of charge and mass at the quantum level reveals a universe where gravity is not just a background force, but an active participant in the dance of particles. Why does Earth have a negative charge and why do smaller masses seem to carry positive charges? It's a hierarchy written into the fabric of the cosmos. Larger bodies dominate with their negative veils, while smaller ones are swathed in positive time particles. This hierarchy ensures that gravity binds the universe together, with each mass playing its part in the grand design. Gravity can be both repulsive and attractive depending on the charges involved. Like-sign masses repel while opposites attract. This duality creates a rich tapestry of cosmic interactions, from the isolation of distant stars to the intimate embrace of planets and moons. The universe is a charged elegy where gravity is the refrain that echoes through space and time. This new vision, gravity is not a blind pull but an electromagnetic rhapsody. It is the universe's song, composed of light, charge, and mass. Every orbit, every fall, every cosmic event is a verse in this endless symphony. By understanding gravity as an emergent property of electromagnetic interactions, we gain a deeper appreciation for the unity and beauty of the cosmos. Let's apply these ideas to a familiar scenario: throwing a stone on Earth. The acceleration due to gravity can be calculated using the ratio of charge to mass and the dynamics of Earth's magnetic field. This approach reproduces the familiar value of 9.82 meters per second squared, confirming our intuition. The trinature of matter ensures that as mass increases, so does charge, maintaining the balance that keeps us grounded. Now let's look at Mercury's orbit around the Sun. Here, the blocked repulsion is negligible, and gravity is dominated by the Sun's mass and Mercury's velocity. The equations predict the observed acceleration, showing that even at the scale of planets, the trinature framework holds true. The Sun's magnetic influence and Mercury's swift motion combine to create a stable, predictable orbit. For Mercury, the repulsive force from blocked time particles is minuscule, just a whisper compared to the thunder of attraction. This faint protest is a reminder that not all forces are equal, and that the hierarchy of charges ensures stability in the solar system. The interplay of attraction and repulsion is delicate, but it is this balance that allows planets to dance around the Sun. Earth's atmosphere, the effects of charge become amplified. Iron-dense air bunches time particles, increasing the repulsive force. During fair weather this effect is negligible, but in thunderstorms it can rival gravity at the quantum scale. Lightning is the dramatic result, as blocked charges break free in a cascade of energy. This amplification shows that gravity's electromagnetic roots can be revealed in the fury of the storm. Gravity's strength and character can shift depending on the environment. In the vacuum of space, it is a gentle, steady pull. In the charged chaos of a thunderstorm, it becomes a dynamic, fluctuating force. This modulation is a testament to the trinature of matter, where charge, mass, and wave interact in ever-changing ways. The same principles that govern planetary orbits also ignite the fury of lightning. Trinature framework is not just poetic, it's predictive. By applying it to real-world scenarios, from thrown stones to planetary orbits, we find that it matches observed values. This empirical confirmation gives weight to the idea that gravity is an emergent property of deeper electromagnetic interactions. The universe, it seems, is more unified than we ever imagined. Every particle, every planet, every storm is a note in the universe's grand symphony. The trinature of matter, wave, mass, and charge creates harmonies that resonate from the quantum to the cosmic scale. Gravity, once seen as a simple force, is revealed as a complex, beautiful melody, woven from the threads of electromagnetism and time. By embracing the trinature of matter, we gain a new vision of gravity. It is not an isolated force but a manifestation of deeper, interconnected phenomena. This perspective invites us to look beyond the surface, to seek the hidden patterns that bind the universe together. The journey is just beginning, and the mysteries of gravity continue to inspire and challenge us. The beauty of this approach lies in its ability to bridge theory and reality. From the abstract equations of physics to the tangible phenomena we observe, the trinature framework connects the poetic with the precise. It offers a roadmap for future exploration, guiding us toward a deeper understanding of the universe's most profound secrets. As we conclude our journey, we see that the universe is far more intricate and interconnected than we once believed. Gravity, charge, and mass are not separate but facets of a single, unified reality. By exploring the trinature of matter, we unlock new possibilities for understanding the cosmos. The mysteries remain, but so does the promise of discovery. Thank you for joining us on this exploration of gravity's true nature.